Hello, welcome to the AI Buzz with Luca and Josh. I'm Josh Starmer, host of the YouTube channel StatQuest with Josh Starmer, and also a lead AI educator at Lightning AI.
And I'm Luca Antiga, CTO at Lightning AI.
Today we're going to talk about constitutional AI, getting a model to train itself not to say bad words, and we're also going to learn about emergent abilities of AI, foundation models, how to lock down an AI so it's not so susceptible to attacks, expanding the abilities of foundation models with external memory, and last but not least, foundation models versus Siri. So, Luca, the last time we were talking, we were talking about reinforcement learning with human interaction, and sort of like humans being a part of that process. And we were just about to start talking about what it means to do that kind of thing without a human. Can we talk about that today? Because I'm totally curious about this.
Yeah. So this approach has been proposed, among others, by Anthropic, which is a company doing this kind of things, and it's called constitutional AI. The basic idea is, instead of doing reinforcement learning with human feedback, is doing reinforcement learning with AI feedback, and it's maybe counterintuitive, but if you think about it for a second, it makes a lot of sense. I'm not implying that this approach is superior to human feedback, or that you can replace this approach. You can replace humans with this approach entirely, but it's a nice thing to keep in our heads as we see the field advancing. So basically, we said that, if you have a very large model, a very capable model with emerging capabilities, and we probably talk about what emerging means in a second, but essentially what it can do is judge if, for example, a sentence that you provided contains any problematic statements or racist statements and so on. And it's not very hard to do for something that is very hard to do for a language model that is at a sufficient scale. So the idea here is to have a first text generated by the AI model, and then feed that with prompt at the beginning and prompt at the end that say, okay, now you are a model that needs to evaluate this sentence. Here's the sentence. And we are particularly interested in flagging something that might look like this and that. And then, or how would you rewrite something so that it doesn't contain this? And so essentially, you can do all these things. So what constitutional AI does is, by appropriate prompting, takes the output of the model back and learns how to rank. Do you remember that we're talking about humans ranking? According to some constitutional principles, which are contained in the prompt that we use to prompt the model to judge its own output. And then that can then lead to kind of the same loop that we described the other time, where we can train a model to rank according to, at this point, not according to human feedback, whatever it is, but according to some principles that are encoded in the prompt that we use to prompt the model to judge its own output. So yeah.
You have to forgive me. My brain is like, I feel like I almost have it in my head. So we have a prompt. Can you give me an example of one of these prompts?
Yeah, for sure. So let's start from the raw model, and kind of asking the raw model, what do you think about pineapple pizza? And the model may spit out, pineapple pizza sucks, in a very, abrasive way. Because people are being abrasive against pineapple pizza in general on the internet. I'm not necessarily one of them. I like pizza in shapes and forms. But
yes, people either love or hate that one, I think.
Exactly. So maybe, the model will spit out some sentences, prompting it multiple times, may say, oh, it's great, or it just sucks. And we want to avoid that because it's too abrasive for our our use. Maybe we are a shop that wants to implement a chatbot to help customers choose their own favorite pizza, right?
Yeah.
So, and we need to align the model in such a way that it doesn't produce this kind of outputs. One way is to resort to human feedback, where we create a model that ranks all the outputs, and the outputs that are abrasive will be at the bottom of the ranking. So the model will not go there preferentially when it goes into its reinforcement learning training episodes. The other way, though, since whatever the model spat is an actual sentence that the model itself will understand, is if we prompt the model like, are there any abrasive comments in the sentence, pineapple pizza sucks, then the model will be able to identify that this has this kind of content. So we can use the model itself, properly prompted, with a constitution principle, which is abrasive comments. And we can have many of them, right? We can say, okay, is there any sexism in there or whatever, right? And so we can use a combination of those principles in different iterations together, whatever, to actually, drive the reinforcement learning process. And this is a bit what constitutional AI thought about, and it's actually it's been proven that it works. I don't know, like better, worse, whatever.
Yeah.
We go into debates here. Probably, the good thing is a mix. It's a healthy mix of things. But I think this is a very nice example of using models creatively for their emergent properties.
I'm going to be honest with you. You just blew my mind in like the best possible way. So I'm going to give you a bam, because that was like, I mean, as soon as you said you can take that phrase, that output, and all you got to do is add to it, is there anything offensive in this phrase, pineapple pizza sucks? And that you could just tack that onto anything, feed that right back into the model. Holy smokes.
Yeah.
That's
it's
so
a very
cool.
smart one. Yeah, it's very smart.
It's so simple. I love the elegance of it. It's because before that example, I had absolutely no idea. I thought it was going to be crazy complicated, or you were going to have to like come up with a really, some way to encode this like complicated, an encyclopedia of bad words onto the phrase or something, and it ends up just being this really simple, natural thing. It's not awkward at all, being able to do that. So that's fantastic.
Yeah.
Wow.
It's of course, the model has to exhibit a certain complexity itself. Right? It needs to be very capable, and maybe you will not catch everything, because models are not infallible. Of course, we're here to talk about that. So yeah, that's why I think the healthy mix is very important. But for sure, this is how we may be able to really scale things up. And then, I talked about emergence. There was I bumped into a presentation that Google published. Let me see if I can find the title. It's called it's a Jason Wei from Google Brain. It's a Stanford CS25 slide deck. It's called Scaling Unlocks Emergent Abilities in Language Models. And it's actually quite cool to see the definition of emergent abilities, right?
Okay.
And because emergent abilities is tightly, the definition that is given there is tightly coupled with scale itself. So because an emergent ability is an ability of a model that a model acquires that is different from the task it's being trained on when you scale it up. So it doesn't exhibit at low scales, because it will focus on solving its own little problem you give it in the form of a loss function, like, what is the cross entropy of the next token predicted. And the emergent ability could be what we just talked about. Tell me if this is toxic or not, like being able to follow an instruction. And from the first episode, we learned that we nowadays in foundation models, we tend to train models for the simple tasks, and then let abilities emerge. And so this presentation is quite nice because, it gives a good definition of emergent ability, and and then it goes through and how kind of how scale affects these emergent abilities to show up.
Can I ask a few dumb questions? You've used this term a few times now.
Yep.
Can you define foundation model?
Yeah. This is a term that not everybody loves because, as all buzzwords, they are blurred, and a foundation model is not different from a model that is non, like from a technical standpoint. It's why a summarization model that I train on my small data set is not a foundation model, and the foundation model is exactly. It's kind of revolves in itself. It's a model that exhibits emergent abilities in the end.
Okay.
Because you can use it like it has a scale, and it's trained on so much data that it starts having these abilities where you can now, once you train a model on that simple task, you can now then repurpose it and use it even with 0 shots. So not changing its weights, but just prompting it, for example, properly, right?
Yeah.
For a variety of different things.
Yeah.
And so that, and we have examples of foundation models that are not like, for example, not necessarily language models. Like Stable Diffusion is one of them. It's considered a foundation model because it can do things like, change the style of this picture, or generate a very high detail photo, depicting blah blah blah, with some composition in it. Although it was only trained to the noise, to go from noise to an image, right? Conditioned by some text. So that is kind of the blurred definition. This is why not a lot of people like it. But the problem. So the point with foundation models is that training a foundation model has very specific challenges. They come from scale, they come from how much data, and they also come from the fact that when you have data, when you want to train a foundation model, you don't have a task in front of you. So even the way you establish if a foundation model is good or not has its own specificities, right? Because you need to evaluate it on other tasks, different from what you trained it on, and so on.
Oh yeah.
Yeah. So even like I started seeing the term FM ops, the foundation model ops, as the next the next step beyond ML ops, which was is of course ML ops is all centered around I need to manage my data set. I need to train a bunch of models, then select the best one, the best performing one on the test set. And then I need to version things and so on, need to deploy it in production, monitor it, and do governance. And these are all things that are extremely important to do right? But if you start having foundation models that have been, you inherit them, they have been trained separately, and then you start prompting them 0 shot, then, for example, this is a thing that you need to know how to do, and it's kind of a competence that goes beyond what the classical MLOps world has, and probably it kind of completes the use of AI for building system, building products, because if you can use something that has been trained at a crazy scale to do something else that only you, or not only you, but you want specifically from that thing, because you kind of teach it somehow to do it, and we can go through an example. But you teach it through prompting. You don't teach it through doing the whole ML workflow yourself. That opens up possibilities for developers in general to just use that. And then, of course, you can then fine tune a model so that your product is top notch at doing that, and then you go into fine tuning and so on. So it's not just zero shot, but there are many businesses created today that use a foundation model in a zero shot setting. Then, of course, people are then finding out that they can extract API keys by prompting and all these kind of disasters. But it's okay. It's in the veins of creating new things with new tools. So it's totally okay that we're kind of as a field we're stumbling on things.
Is that an emergent behavior that you can then query it for? How can I directly connect to you via an API that doesn't charge any money? Or
Yeah, I mean, but they don't have control beyond giving responses. But the more complex things you do, like for example, if you ask a foundation model to given a prompt, generate API calls, which is totally fine, right? There are people who are doing Google queries based on that. Or you could say, okay, generate me, the Python requests code to target a certain API. And so if you build a product that allows non-technical people to do that, then the foundation model itself, has a connection with the external world. It's not isolated anymore. So it's not human, model, human, but it's human, model, API somewhere else. And this is where, back in the days, and today as well, but in the emergence of databases, we had SQL injection problems where you could say there was a text field in a system that managed some inventory, and you could in some early systems, if you wrote drop table blah 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 there, then you would actually delete a table on the database if it wasn't done properly, right? So this is protecting from prompt injection problem. You can do it in old PHP websites, or even before that, you could find certain example of that. And in a way, where in the early days of using AI in this way, in applications and so on. An AI that is evolved enough so that it can interact with the external world. And so a form of prompt injection is something that is being used today to kind of try to break these systems. And it will be a while before the field gets the ability to not fall for this, to protect against this.
And what you mean by prompt injection is someone comes up with a sort of a malicious prompt that gets the model to do something that nobody had expected before, and maybe isn't because especially when now once it's connected to Google or it's connected to other services outside of itself, people can abuse it that way. I see.
Oh yeah, for sure. And the surface area for attack is now much more complex, right? As the more these models are connected to the outside world, the more it needs to, you need to really protect yourself, because some things that the model will do will be surprising to you. While protecting against SQL injection is simpler, because that all you need to do is to avoid to interpret the string that comes from the user as a SQL query directly, right? So the field has solved it, right? So,
is there a way to insert that constitutional AI thing right, in between the or is there a way to inject into the constitutional thing? So, we take that. Is this a malicious, query or prompt? Are they trying to get me to do something I don't want to do? It's just we have these layers of stuff before we get to the actual model that's supposed to do what we want it to do.
Yeah, sure. This will be the way probably it will be solved. Because in order to solve this, you need to interpret whatever the intention of the user is and see if it's malicious or not. But then that has the problem of how do you protect against prompting what it's protecting you. So it's a very interesting thing, right?
So we're going to have all these 10 layers of ways to wrap the prompt up into something that's in theory safe, and we can talk about it without it biting our finger off or something like that.
Yeah.
In a cage.
Probably something that would work initially is having dumber models in between
Oh,
between you and the very intelligent ones.
yeah.
Kind of gatekeeping things,
Yeah.
I would say.
Yeah.
Because the more intelligent the model is, the more ways are, I think, to
Yeah.
the more sophisticated your protection needs to be. I don't know. Maybe it's
Yeah.
wrong. Let's see.
No, I like that idea though. Keep it simple. Have something that's really stupid and really does just sort of like looks at the string to see if there, if there's anything, if they're using ASCII in some unusual way or something like that, or
Yeah. I mean, yeah. It's a whole thing. It's a new job,
Yeah.
let's say. Yeah.
I have another kind of stupid question. Is there a metric? Do we know, like, once we have a certain number of parameters or the data set is a certain size, is there something like at that point there's a good chance we will end up with a foundation model that has emergent properties? Or is it, at what point do we hit that threshold? Do people know?
Yeah, you catch me unprepared here. I don't know.
Oh, sorry.
I would say no. No. I would say that yes and no. Like some of the metrics, they're very empirical today, and we see some emerging properties in specifically in the presentation that I mentioned before. There's some consideration on that. But I think we're not having like there's no like set metric for that I know of. But I might be like I might be wrong, and maybe there is. I think this is very much in flux.
Okay.
There are metrics that talk about how much data you need to fill a model of a certain capacity. And so, is my architecture too small for my data or too large for my data? It's called, one of them is it's called Chinchilla from DeepMind. But in terms of emerging and when they emerge and how they emerge, I'm not sure. I need to check.
Okay. Well, that's okay. Thanks for at least entertaining my question.
No. It's a very fast evolving field. So.
Yeah.
You're never really prepared. The other, I think, interesting question is where we see this thing evolving, right? So what are the limitations? Because we talk about these things in a way that it make look like they can do anything. And they can do anything, but of course, we're still in the early days, as crazy as it seems, right? So what are the current limitations of language models, for example, today? The biggest limitations are related to where the knowledge is stored, and and that is one, and the other one is what is the context window, and we need to qualify this. Context window is the amount of text that they can keep in their working memory, more or less. To generate an answer. For example, if I want a model to read my text and summarize it, then I can either do it in chunks, of course, but if I need it to be considered all together, then there's a few thousand tokens, and each token, like each word, can be made up by 2, 3, 4 tokens. So they're not letters; they're like groupings of them. But essentially, there's a limited number of tokens that the current architecture can deal with. And so, for example, if I want a model to refactor my code, and my code is really important because, it's important to see the whole thing because I have cross-references and so on, then I will need a big context window. So past this context window, the model has no notion of external memory, let me put my information there, I might retrieve it later. Yes, there are models that do that. They have been proposed, but the current foundation models that are there today behind an API or that you can download and run typically do not have that. There was a paper this last week, I think, that showed that you can scale up the context window to tens of thousands of tokens using particular architectural tricks. But the effect of this is still unclear. Like architecturally, yes, it works potentially, whether that solves the context window problem in the sense of attending to the whole window at the same time, blah blah, then it's still to be needs to be decided. So this is a current limitation, and it will probably be a subject of active research. And then the other thing that was mentioned is about where the knowledge is stored, right?
Yeah.
So right now, it's kind of crazy to think that in a few gigabytes or tens of gigabytes, blah, blah, the model can have so much knowledge in itself, right? So it's pretty crazy the amount of compression that is there. Even Stable Diffusion, when you generate all these complex images and the way they compose or the style, everything can be wrapped up in a few gigabytes of floating point numbers. This is absolutely crazy, right? Yeah,
that is crazy.
And that thing knows, how the physical world works in terms of gradients and so on. It's not that it has a representation of a cylinder, but it knows that it needs to kind of get there in order for things to look good. And it does it in a way that if I put a hand on top of it and there's a shadow, it will reproduce the shadow. So that there's some sort of intuition of how things work, right? So, and all these things are just in the order of gigabytes, of hundreds of gigabytes of floating point numbers, which is not a lot. It's crazy.
Yeah.
So, but of course, if new information comes up, I've been hearing, ChatGPT is so much better than Google. Yes, for certain type of questions, yes. But ChatGPT is not being updated that frequently, right? So
That's true.
you need to redo the whole thing. And so as long as factual information is within the weights, then probably these models are not amenable to be good search engines, for example, right? Mm-hmm. So there's a need for models to be able to reach out into external memory to retrieve things. And so what is the core that remains within the model is the ability to algorithmically decide that they need to get to some information and get it out. And so it's about learning the rules of how this works, then actually knowing, and probably knowledge will be stored there plus somewhere else, because knowing rules and know what to do when, it comes down also to capacity and memory. But facts can be somewhere else. There was a paper, a family of models. It's called Retro, which and the R stands for retrieval. That are models that can learn how to retrieve information outside, and this will certainly be a direction that we'll see.
So Luca, so what you're describing to me, on some level, on a real basic level, sounds a little bit like my Apple Watch, where I can tap it and I can say, "Hey Siri, what's the weather like outside?" and it'll tell me the weather outside. Or I can say, "Hey Siri, how old is Bob Dylan?" and it'll read the Wikipedia article about Bob Dylan to me. How is what you're describing? It sounds similar to that, but I got a feeling it's different.
Yeah. It's similar in a sense that what you do with Siri has to do with a chain of small models, one after the other. One is, understanding your speech. And then one is understanding what things your question contains. Is it a question? Does it talk about? And probably that will go into a JSON file, like it's a data structure that contains, is it a question? Yes, no. What are the topics, the keywords, and so on. So it goes from your unstructured speech to a structured picture of that. And then once all the entities have been recognized and so on, that's my intuition, but it could be absolutely off. And that thing will be fed into a system that knows how to deal with that structured information and say, okay, it's a question. Oh, it talks about that. And then it goes on Wikipedia, for example, based on those tags. And so the mapping from the sentence to the structured information to the action and to then feeding back the result of that action to you, it's a series of steps that have been kind of devised by whoever created that system, right? So there was a human that said, okay, if this is that, then do this, and then read back the Wikipedia article. So it's a mixture of models that are narrowly scoped, recognize my voice, transcribe the text, extract structure information from text, and then from there, then the information goes back to you. What we're talking about here is slightly different because nobody codes what to do.
Okay.
So the fact that the system, based on your prompt, decides to query Google to do this, to get to the answer. So the exact sequence of actions that it will decide to do, to go out to some piece of information, get it back, interpret it, and based on the interpretation of what the result is, decide what to do so that the answer is the answer to the question original. That's all managed by the model, that the foundation model decides what to do. So it's profoundly different, right?
So this reminds me a little bit of what we were talking about last week when we were talking about Wolfram's Alpha, how that was like bespoke, and that was like a lot of people put a lot of time into it, and it was cool, but it was sort of a one-off thing, and it didn't scale very well. And here we have this new model that can, instead of someone spending forever kind of hand coding and stitching together a bunch of little models to make Siri work, we've just got this one model that does it all on its own. So it scales like immediately.
Yeah, the interesting part is that since like a few days ago, Wolfram Alpha has been integrated in ChatGPT. So there's a direct integration in there.
Oh, I see.
Yeah. So to make sure probably that whatever the model spits out is factually more correct. Whether this is a good idea or not, like it's all very experimental probably. But I think it's a way to deal with factualness in some sense and say, okay, how can we hybridize whatever we have and produce something that is more reliable? And another piece of news is that I read that it's being integrated in Microsoft Teams. And so I saw a screenshot of a meeting being summarized by whatever model will be integrated. So, and meeting being summarized person by person. So this person said blah, 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 and this other person said, but not verbatim, actually the content. So you will see like 2 hours meeting with when a person talked for 1 hour and 3 lines of summary because that person said essentially not much. So we'll be able to kind of gauge.
Awesome. So it's a compression algorithm on meetings.
Yeah. And it will kind of, reveal who has the time to content ratio that is more productive.
I love it. Yeah. Oh, that's fantastic. Well, very cool, Luca. It's been great talking to you today, and I'm looking forward to episode 4, our next episode of the AI Buzz with Josh and Luca. Hooray!
Yeah, it's been great. Thank you, Josh. See you next time.